In this video, we're going to have an introduction to functions. More specifically, quadratic and linear functions. So what is a function, you may ask? When you're thinking about functions, you should imagine them as machines. Let's say the function called f is a machine called f. If I put number 5 into this machine, on the other side, we'll get 10. Well, how did this happen? How did 5 become 10 after going through this machine? Well, to understand that, let's look into what's inside this machine. Inside this machine, if you unpack it, you will see this notation here. F of x is equal to 2x. Now let's look at what these mean. F, in this case, is the name of the function. This can be any letter, in fact. This can be G or H or L or T and so on. X is the function's variable. So then the rest is, and this is the rest of the equation. This is its content. This is what f of x is equal to. So we're gonna define this more. We're gonna focus on this more now. Okay, so let's look at what's happening here. Before we start, we should mention that if I substitute this x with a value, then each x in the function is going to change to that number or to that value. So what I did here in this machine was to substitute x in this f of x to 5, and f of 5 is equal to 2 times 5, right? Because this x here, that changed to 5 because of this variable. So therefore our answer is 10. Easy. Okay, how about we look at another example? As I told you, this f can be substituted with g, for instance. So let's say g of x is equal to actually, let's say 5, x plus 5. So let's say that x is equal to 2. You can pause the video and try for yourself. But we're going to continue now. So g of 2 is equal to 5 times 2 plus 5. And this is equal to 10 plus 5 is equal to 15. There we go. These functions were the x is not taken to any power, but it's multiplied or not multiplied, or it's just simply x. These are called linear functions. This is because when we plot this function on a graph, it will be a straight line. So it will look like this, for instance. So now let's look at quadratic functions. Might sound scary, but it's not really that scary. Quadratic functions are functions that include x taken to the power of 2, so x squared. Quadratic functions, when plotted on a graph, will have the shape of a parabola. This shape is called a parabola. This parabola can either be upside up, like so, or upside down. It depends on the operator in front of our function. So if here we have a plus, then it's upside up. If it's negative, then it's upside down. So you should think about this way. Plus is happy, negative is sad. Okay? So let's look into the notation. I can give you the function f or h of x is equal to, let's say, x squared plus 4x plus 5. And we can set x to 2. You can pause the video and try solving this yourself. So with x being 2, our new equation is h of 2 is equal to 2 squared plus 4 times 2 plus 5. So 4 plus 8 plus 5. So 17. And that's our answer. 17. Okay. I think we got the idea of functions here, this notation. So let's look at how to draw functions. Okay. So let's plot a graph here. Just a rough sketch. Put a scale. Just roughly, just circa. Okay. Let's say we have the linear function t of x is equal to 3x plus 1. To draw a function, in the beginning at least, I would recommend you using a table. So the table would look something like this. Divided into 2, x and y. Okay, this y you can write, because y is basically the same as f of x, or t of x in this case. But we'll stick to y. So let's put some point in. Let's say we put in the point -1 in x. Then our it will look like this, right? T of -1 is 3 times -1 plus 1. So -3 plus 1, that's -2. So our y value for this point is going to be -2. So we can put one on a point on x -1 and y -2. So here. Now let's go over to the next one. Let's plug 0 in. 0 times 3, that's 0, plus 1, that's 1. So our y value will be 1 at 0. So we are here. Let's put a point here. All right. Let's plug one more in. 1, f of 1. I guess I didn't take this away now. F of 1. 3 times 1, that's 3. Plus 1, that's 4. So at 1, the y value is 4. So 1, 2, 3, 4. And then we can pretty much see how this function is going to look like. So the only thing left to do is to just draw a straight line. That's your function. It's as easy as that. Let's look at graphing quadratic functions. So I can remove this now. Let's say f of x is equal to x squared plus 5. We'll go easy for this one. Using the same method, we can put up a table. But before we start, I'm going to mention some things about quadratic functions I haven't mentioned yet. Let's just draw a dummy function here. That's not something that we have calculated or plotted points for. And let's analyze. At the point where this function turns sides, see, we go like this. We go downwards here, but we go upwards on the other side, right? At the point where that switches, so here, that is called the vertex. The place where the function cuts the y-axis, so here, in this case, is called the y-intercept. Where it cuts the x-axis 2 times, those are called the x-intercepts. So you should keep these in mind, because they'll help you throughout your IB career. These concepts can also be taken to linear functions. But here you have one x-intercept and a y-intercept. and no vertex, obviously. Okay, let's go. Again, x and y. So by now we understood that y is the return value. So let's start with plugging in -1 into our x. -1 squared, that's 1, because -1 times -1, that's 1, right? Plus 5, that's 6. So let's extend our graph a little bit. Okay, so we'll put a point at okay, when extended, we can put a point on -1, 6. Okay, so let's go to the next one. 0. 0 squared, that's just 0, plus 5, that's 5. So at 0, we are on 5. Okay, now let's go to 1. 1 squared, that's just 1, plus 5, that's 6. So we'll go back up to 6 at 1. Let's do a couple of more. Let's go to 2. 2 squared, that's 4, plus 5, that's 9. So let's extend. So 7, 8, 9. So at 2, it's on 9. And we see kind of this pattern, right? That what happens on this side happens on the other side as well of the vertex, right? So we can safely plug a point put a point on -1, 9. And then we can see the function, right? So let's draw it. That's their function. Pretty cool, right? So -1, that was 6. Because of 1, 2, 3, 4, 5, 6. 0, that was 5. And that's our vertex point. 1. 1, that was 6 as well. And 2, that was 9. And then hence, -2 is also 9. So you should see that it's mirroring. All right. Let's look into one last thing. I'm going to draw you a shape now on this graph, just roughly. And I want you to tell me, is this a function or is it not a function? Why or why not? This is definitely not a function. And the reason is that a function can never cross the y-axis 2 times. Hence, the y there can be only one y-intercept. But here, as you can see, it cuts the y-axis 2 times. which is not something that a function would do. So this is not a function. So when you see something like this and they ask you if it's a function, then no. This is not a function. This is something called a relation, but we're not going to go into that now. On the other hand, if I give you a function like this, which is called a cubic function, is this a function? Well, obviously it is because I just said so, but is it a function really? Yes, it is, because it doesn't cut the y-axis 2 times. It only has one y-intercept, right? So then, is this a function? No, it's not a function, because as you can see, it cuts the y-intercept 1, 2, 3, and 4 times. So it's definitely not a function. So I hope you got the idea of this. All right, that was it for functions. This is the introduction to functions. I hope you understood a lot. And of course, as always, if you don't understand something, you can either read our guide to functions on www.MezeiMaths.com, link in the description, or you can always refer to our Reddit group for help, r/MezeiMaths, link in the description for that as well. Thank you for watching this video, and have a great time doing functions in mathematics.